Good day. For those of you who do not know us, we're the instructional staff for EC 150. Professors Hiran Patel, Werner Dietl, and Douglas Harder. In this topic, we're going to look at logging execution. So this is the fifth in a sequence of 6 topics on C assertions, code development strategies such as writing skeletons, testing your code in main, commenting your code appropriately, and now using print statements for debugging, or in other words, logging. The last topic, which will be next, is using tracing for debugging. In this topic, we are going to describe the purpose of logging. We will consider how it can be used for debugging and explain some of its limitations. All right, you have an assignment or project and you've written a function. It compiles and it doesn't work. The easiest step is to log your code with the standard cout statements. Now, as you may recall from Star Trek, a log is a detailed history of what is going on. Well, that's what we're going to do here. We're going to print to the screen information about the state of the code during execution. Here is a version of the high-low game. In the game of high-low, there are 2 players, players A and B. Player A has a hidden number between 1 and 100. Player B tries to guess that number. Player A helps the player who is guessing by indicating whether or not the guess is correct, too high, or too low. So in this case, the computer is going to be the one guessing. So the computer starts by having a low number, 1, and a high number initialized as 100. Then it goes into an infinite loop. The guess is the average of the 2 numbers. The computer then prints out the guess and asks whether or not the guess is low, correct, or high. The computer then queries the user using standard cin to get a response from the user. All right, so if the user indicates that the guess is correct, the function terminates by just issuing a return statement. Recall that the return type was void. Otherwise, if the guess was low, and notice that we're allowing either lowercase l or uppercase L, then we update the lower bound to be the current guess plus 1, because our guess was too low. So if our guess was 50 and that was too low, we will update low to be 51. Otherwise, if the guess was too high, then that indicates that we should be guessing on a lower range. So if originally we were guessing from 1 to 100, and our guess was 50 and the user indicated that 50 was too high, then our upper bound will now be set to be 49. Thus we will carry on guessing a value between 1 and 49. Notice that we make allowances for the user having entered the wrong characters, in which case we do nothing and we just play again, and neither low nor high has changed, so the next guess should remain unchanged. At the bottom, we have an assertion that says we should never get here. Why? Because the only time we should ever return is if the user has entered either a lowercase or uppercase c, indicating the guess was correct. Now, suppose that your hidden number is 35 and you're playing against the computer. The computer asks, my guess is 50. Is it too high, low, correct? You enter, it's too high. Computer guesses again, 24. Well, that's now too low. My guess is 36. That's too high. 29, too low. 32, too low. 33, too low. 34, too low. Wait a second. It guessed 34 again. It just guessed 34. Why is it guessing 34 a second time? All right, so now we'd like to look back at our code. And if you look at the code, it doesn't seem that there's any real issue, because this is exactly how you would play the game in real life. So what's going on here, and why is it guessing 34 twice? Well, let's add a single cout statement that logs the data. So here I have a cout statement. I put a few greater than symbols just to indicate that this is output from the log, and then I print the local variables low, high, and the guess. All right, so now I can rerun the program, but now every time I print out a guess, I will also, prior to that, print out the values stored in these three local variables. All right, let's play again. And again, the hidden number will be 35. However, this time we will play it with logging statements on. So let's see what happens. Well, there's low, high, and our guess. All right, so my guess is 50, too high. My guess is 24, too low. My guess is 36. That's too high. My guess is 29. Well, we're going to indicate that that's too low, but notice at every single step, the values are printed out, and it seems that, well, everything seems to be working so far. Now you'd think, wait a second, the average of 25 and 35 should actually probably be 30, not 29, but that's okay. So let's say that that's low. My guess is 32. Okay, that's reasonable again. Okay, so let's keep on playing from here. Guess is 32. That is too low. So low is 33, high is 35. Well, the average isn't really 33, is it? Well, still, 33 is too low. So we have 34, 35, and the average is 34. Okay, that's okay. So that's low. Now let's take a look at this. 35 is low. 35 is high, but the average is 34, and now it's stating again that the guess is 34. What happened here? All right. So you determine that the problem seems to be with the calculation of the guess. So taking a look at this code, well, when low and high are 35, you suddenly remember that division truncates. So if low and high are 35, then guess is initialized with the value 35 divided by 2 plus 35 divided by 2. But 35 divided by 2 is 17.5, and the fractional part is thrown away. So it's actually 17 plus 17, which is equal to 34. So if you say it's too low, then low is once again updated with 34 plus 1, which is still 35. So you try the following instead. The guess is now low plus high divided by 2, and if you rerun the program, you find that it works. Now, using cout or logging is a simple debugging technique. It's fast and dirty. You just add a cout statement and you take a look at the output. However, this can be a horrible way to find a much more subtle or complex bug, so it's not always going to be all that easy. If you don't know where the issue is, you may end up writing out dozens of print statements throughout your source code. This can lead to issues because you must remember to comment out or delete all such logging statements prior to submitting your code. Otherwise, you're likely going to fail because we look at what your output is and we do not expect to see your logging statements. However, logging is actually used in industry. Many applications keep something that is called a log file. Into that file, the application will occasionally print statements regarding the current state of the application, perhaps what certain variables are storing at a particular point in time, or what the most recent transactions were. Now, if the user submits a bug report, the user can also simultaneously submit that log file, and then the developers can examine the log file to help track down the cause of the bug. Of course, if you don't log the right variables or the correct data, this isn't going to help the developers. On the other hand, if you log too much information, first of all, it's going to use up the user's memory, both volatile and persistent, but also if you print too much information, the developers have to wade through all that data to try to figure out what is relevant and what is irrelevant. So consequently, the next topic will look at using tracing for debugging as opposed to the process of logging. Following this topic, you now have an idea how you can debug your code using a cout statement. This is essentially logging. Now, you understand that this will work to find simple bugs, and it's probably what you're going to do if you've not already used it. However, it's important to note that this is still used in industry. Again, you should also understand that it may be less optimal to use logging to find more complex or more subtle bugs. Most importantly, if you don't know what the cause of the problem is, that means you probably don't know what you have to print, in which case it doesn't necessarily help. You may end up printing everything to the screen, which is actually going to end up being more of a time waste than of a benefit. And so in the next topic, we will look at tracing. Here are some references, acknowledgements, the colophon, and a disclaimer. Cheers!